In this tutorial, we're going to learn how to compare the various protons in a compound and determine which proton is the most acidic proton. Let's take this compound as an example. Let's go ahead and draw all of the protons that are in this compound. And we essentially have four different kinds of protons. There's these protons here, this one, these two, and these. And we need to decide which proton is the most acidic. Is one of these protons the most acidic, or this one, or one of these, or one of these? Now, we've already seen a tutorial for how to compare the acidity of two different compounds. And in that tutorial, we saw that there are four factors that we use for comparing stability of conjugate bases. What atom is the charge on, resonance, induction, and what orbital is the lone pair in. Now might be a good time to go and review that tutorial and go over the rules for comparing acidity of protons. We're going to use that here to do the exact same thing as we did over there. But now, instead of comparing two different compounds, for example, instead of comparing one compound with another compound and saying, is this proton more acidic or is this proton more acidic? Now we're looking in one molecule and saying, which proton in the molecule is the most acidic proton? And in order to do that, we're going to need to draw the conjugate base of each one. This would be the conjugate base if we pulled off one of these protons. This would be the conjugate base if we pulled off this proton. This would be the conjugate base if we pulled off one of these protons. And finally, this would be the conjugate base if we pulled off one of these protons. And what we need to do now is compare all four of these possible conjugate bases using our four factors and determining which of these conjugate bases is the most stable. Whichever one is the most stable, that will tell us which proton was the most acidic proton. Let's see how this works. Let's start with what atom is the charge on. Here the charge is on a carbon atom. Here it's on a nitrogen. Here it's on a carbon. And here it's on a nitrogen. So we immediately gravitate towards negative charge being on nitrogen. Negative charge being on nitrogen is better than negative charge being on carbon, or here again on carbon. Why? Because nitrogen is more electronegative and can better handle the negative charge than carbon can. So we immediately gravitate towards this one and this one, both of which have N-. Then we move to our second factor, resonance. And we look for where we have resonance. This one doesn't have any resonance. It's C- with no resonance. We can pretty much cross that one off. Here we have C-, but it does have resonance. There's a resonance structure kicking up the negative charge up onto the oxygen. Here there is no resonance, and here there is resonance kicking up onto the oxygen. So although this is N-, but we have an N- here with resonance, so we can cross this one off. And we're left between these two. We just have to decide, is it better to have the negative charge spread out between a carbon and an oxygen atom? Or is it better to have the negative charge spread out between a nitrogen and an oxygen? And the answer is, when we compare, nitrogen-oxygen is better than carbon and oxygen. So, in fact, let's go ahead and draw out that resonance structure. O-. Ran out of room here on the side of the screen, so instead of writing it as NH2, I put one H up here and one H down here. But here are our resonance structures, and we see that we have the negative charge spread out between nitrogen and oxygen, and that's going to be better. We don't have any inductive effects or orbital effects here, so this is going to be the more stable conjugate base, the most stable conjugate base of all the possibilities. And the most stable conjugate base comes when we have the negative charge right here on this nitrogen. So which proton is the most acidic? The most acidic proton is the one that gives us the most stable negative charge, the most stable conjugate base. And that's this one right here. If we pull off this proton, we get a negative charge on the nitrogen atom right here, and that negative charge is resonance stabilized up onto the oxygen. So we see that when we're comparing the protons in one molecule, we use the exact same procedure that we used when we were comparing protons in different molecules. That is, for each proton, we imagine the conjugate base, and then we compare those conjugate bases using our 4 factors. What atom is the charge on, resonance, induction, and orbitals. And after using those 4 factors, we can determine which conjugate base is the most stable conjugate base, and that in turn tells us which proton is the most acidic proton.